Hi there. My name is Frode Eika Sandnes, and I'm with Oslo Metropolitan University in Oslo, Norway. I will present our study where we are comparing the pie chart with the bar graph. The motivation for this work comes from my meeting with the students where we are discussing visualizations in reports, statistical analysis, or even applications where we are making some visualization systems. And I noticed that often my own views are different from those of the students. I, I, I don't know why, but I have traditionally been thinking of bar charts as superior to pie charts, and I tend to use bar charts, and I really never used pie charts. Actually, this paper is the only example where I actually included a pie chart in the paper, so it's a bit of an exception, that is. But so when I say, bar charts are better, then students usually protest. And they will come with various arguments, such as, I simply prefer pie chart, or pie charts are easier to understand, pie charts are more effective than bar charts, or I don't care what you say, I will use pie charts anyway. So then we have a very nice, interesting discussions on this topic. I'm not the only person to hold this opinion that uh, that bar charts are better than pie charts. If you look at scientific papers, more frequently you will find the bar charts, whilst pie charts occasionally you'll find them, but they are few and far between them. So I think when I see a scientific paper with a pie chart, I will tend to look down on that paper and think it's not that good. Now, one of my favorite visualization experts, Stephen Few, he's written this white paper called Our Irresistible Fascination with All Things Circular, where he sort of makes a little bit fun of this phenomenon and pie charts. Clearly, he is not in favor of pie chart. He prefer, or he argues strongly for using bar charts or other types of charts. And in this paper, he describes how when he goes and gives presentations about visualizations, how often people will protest and defend the pie chart, and where he constantly is in a battle with these people. And his main argument, which I think is a really good argument, which I subscribe to, is that if you look at this pie chart on the front of this paper, you will see that when you're trying to compare slices in the pie chart that are very similar, it's very hard to tell which one is the smallest or the biggest. So it's this sort of extreme value. Whilst if you look at the bar chart, it's much easier here to see which one is the smallest and which one is the biggest. So this sort of is the inspiration behind this work, because Stephen Few, he just have these opinions, but he hasn't really presented any empirical evidence on this. And we have not been able to find any actual evidence on these things with extreme values as well. The choice of visualization mechanism is not only a matter of personal opinion, it can also have a significant impact. Imagine that you have a control room where you are making important decisions that could affect people's lives in a serious way. And imagine that you're in a situation, an emergency emerges, and you have about 2 seconds to make an important decisions that could affect people's lives in a serious way. Now, if you have the wrong type of visualization tool that gives you the wrong impression, then you might make a wrong decision based on what you see. So it's immensely important to have a suitable visualization mechanism that will prevent you from making any errors. So that is also the motivation behind this and our interest in this work. There is quite a lot of work on pie chart and bar graphs and related visualization mechanisms. So I'll just show you a few here, and you can find a few more of them in the paper. One of the issues people have looked at is the relationship between the angle, the arc length, and the area, and how that affects the perception of various quantities. Another issue that has been studied is that of bias when you are looking at part of a whole. When participants are making a part of a whole assessments, they found that there tends to be a systematic bias. Ian Spence has a very nice review of the 200 years of pie chart history since it was allegedly invented by William Playfair. And when we look at angle, they even argue that the angle is the least important thing, and because of that, donut charts have been found to be as efficient as the pie chart. And another issue that is received some attention is that of the angle perception, how sensitive we are to angle perception and just a noticeable angle. And what one has found is that if you have horizontal 90-degree angles or close to 180 degrees or 270 degrees, sort of the right angles, that's where we are more sensitive. Whilst if you have tilted angles, we are less sensitive to the angle. The same actually goes for length, and therefore there's also an argument that things relating to angle is not as efficient as things relating to length, because humans are better at distinguishing between various lengths side by side along one dimension. This chart is taken from the last paper, and it shows how participants' perception varies with the angle. Now, if we are to find the smallest pie in a pie chart, the smallest slice out of a set of slices, what do we do? Well, we can look at one of those three things. We can either look at the angle, we can look at the area of the slice, or we can look at the length of the arc. Now, determining what is the smallest or the biggest item when you're comparing angle, arc length, or area is quite difficult because you can't put things side by side. There is also literature in the research from the cognitive psychology literature, which shows that we are not very good at comparing areas as well, or assessing area. Now, if we have a bar graph like this, it's much easier to identify the smallest or the largest item. We see it more or less immediately because we can see these lines, virtual lines going across, and then we can see that the height signature for the smallest graph or bar is here. For this work, we formulated three hypotheses. The first hypothesis was related to search time, and we hypothesized that it would be quicker or faster to identify smaller or the small or the big value using the bar chart over the pie chart. Our second hypothesis was related to error, and we predicted that with the bar chart we would get fewer errors than we would with the pie chart. And our third hypothesis was related to participants' perceptions, and we predicted that given these tasks, participants would actually also prefer to use the bar chart to identify the extreme values compared to the pie chart. That is, they're given a specific task. To find the answers to this research question or these three hypotheses, we chose a within groups experimental design, and we had one independent variable, and that was the chart type. It has two levels, pie or bar chart. we had 3 dependent variables: search time, errors, and preference. We recruited 20 participants. Half of these were male and half were female, and the age ranged between 20 to 56 years of age. All of the participants had also completed secondary education, so we would assume that they would have some familiarity with both pie and bar graphs and how to interpret these. As basis for the charts that we showed to the participant, we created 10 datasets. Each dataset had different numbers of various magnitude in random order. Then for each dataset, we generated 2 charts, one pie chart and one corresponding bar chart. So we ended up with 20 charts based on the 10 datasets. These charts were shuffled into random order so that they will be presented in random order. And all these charts were created using Excel. We removed all unnecessary visual elements that would sort of disturb the perception of in the experiments. And we also decided not to use color to distinguish between different elements. So for the pie charts where we had different slices, we used different shades of gray, whilst for the bar chart we used one shade of gray, as you can see in the example on the top here. We showed these charts to the participants, and for each chart we asked the participant to find the smallest item, and they had to then indicate that smallest item either by pointing at it or uttering the identifier of that item. Each participant was tested individually in a quiet meeting room, and the timing measurements was done using a stopwatch, and the time from when we started showing a chart to when the participant indicated their answer was the task or search completion, search time, and the experiment was anonymous. We will now look at the results, and we will start with the search time. Let's look a bit closer at these data. If we look at these results, we see a clear indication that the pie chart took much longer than the bar chart, which took much shorter. And these differences were statistically significant. The next thing we looked at was error. And if we look at these error results in a bit more detail, the error results show that with the pie chart, the participants made many more errors than they did with the bar chart. And these results were also statistically significant. Note that we used, of course, a non-parametric test to compare these results. The last result we looked at was the perceived accuracy of the 2 visualization types. Let's look at these in a bit more detail. The perceived accuracy of the pie chart was quite low, whilst the perceived accuracy of the bar chart was much higher, and this difference was statistically significant. Again, we used a non-parametric statistical procedure to do the test. Now, what does this all mean? What is quite reassuring is that our results seem to be aligned with the recommendations by the visualization experts and the other literature. Clearly, it is faster to identify the smallest items with the bar chart compared to pie chart. In this experiment, we only looked for the smallest items, but if we had also included the largest items, we didn't do that, but if we did that, we would probably also find the same results. It's natural to expect that. Another issue was that we found nearly no errors with the bar graph and much many more errors with the pie chart. And if you are in a critical situation where you can't afford to make mistakes, clearly you want to use a visualization technique which results in fewer errors. And finally, we found that the perceived accuracy was higher with bar chart, nearly perfect. And that is related to the given task. If we had a different kind of data task, such as assessing a portion of a whole, the result might have, the preferences might have been different. This experiment clearly is not perfect. The obvious limitation is that we had a very small sample, only 20 participants, so we should be quite careful in making any generalizations. Another issue is that we had a limited cohort who had all completed secondary education. With different types of participant groups, we might have found somehow different results. Methodologically, we decided to use shades of gray. We are uncertain whether that somehow affected the results, and one alternative would have been to instead use just outlines of the various slices, especially then for the pie chart. We also forgot to remove the grid lines in the bar charts, but we do not think that would have affected the results. And one afterthought, though, was that we asked the participants after we showed them the graphs which one they preferred. We should probably have also asked the participant beforehand what a prior preference regarding their impression of the two types of charts would be. That would have been possible to make some very interesting comparisons. So, what can we learn from this study? If the task is to find extreme values, such as the minimum or the maximum, you should probably use bar charts. Also, if you have an online system or something that goes live where you don't know exactly what the data will look like, you might also want to consider using a bar graph because you cannot predict what the data will look like. So then also I would recommend a bar chart. If your task is to illustrate imbalance, such as gender imbalance, for example, then you could use either bar or a pie. It probably doesn't make that much of a difference, and it's just a matter of personal preference. Now, if the task is to find part or identify part of a whole, then probably pie charts are a better choice. Thank you all very much for listening. If you have any questions, you can send me an email, or I will try to answer your questions now live.